Now, our next speaker is Peter Wilson. Peter has over 30 years of hands-on experience in noise and vibration, so he fits into the theme very well. He has not only developed a number of unique and innovative noise and vibration control techniques, including an award-winning fan noise control technology, but also developed the AIOH competency training course in both noise and hand-arm vibration. He was also asked to provide the best practice hand-arm vibration management presentations on the HSE roadshows to launch the hand-arm vibration regulations in the UK. Peter is in demand as an entertaining and sometimes controversial regular contributor at conferences for organisations. So looking forward to this. Particularly, he's presented at BOHS, AIOH, EFF and IOM with a refreshingly pragmatic and practical approach to the subject of noise and vibration management. So if you could please put your hands together and welcome Peter Wilson.
Let's just test the microphone. Can you hear me? Yes, good. Good morning. For me, it's extremely morning because it's 20 past 1 a.m. for me, jet lag. Thank you very much, AIOH, for inviting me over here. Fantastic venue and a lot of dedicated professionals in the room here. We're talking about hand-arm vibration. One of the problems, you're very lucky today. You've had a noise and a vibration presentations back to back. Just how lucky is that? One of the problems with both subjects is they are regarded as technical, and unfortunately this tends to engender a lot of mistakes and misrepresentations and misunderstandings that can have a serious effect on people. So what I'm going to do is just go through some of the myths. This is some of our background, which we talked about already. One of the things is, having done loads, we're the major supplier of competency training in hand-arm vibration and noise in the UK, so we see more reports and more risk assessments and more risk management programs than with virtually anybody else. And one of the things I find immensely depressing is on the roadshows, the questions that are coming up, hand-arm vibration regulations, do you have to do this, can you do this, why? 10 years later, the same myths and the same mistakes are being made. And that's what this is about. Now, this is here because obviously there's only one way to mount a toilet roll on a holder. It's this way, not that way, obviously. But the thing about this is, a couple of years ago, on one of my workshops, there was a doctor, and he said, one of my patients came to me the other day, and he has got severe hand-arm vibration symptoms. He can't wipe his own bottom. And that really brings home to you why we do this, why it's important that people get it right, why it's important people don't make mistakes and underestimate the exposure of people. It can mess with your life, seriously. And that's why it's so important to get it right. And there's a lot of myths. And one of the problems is that these myths are played upon by suppliers, by consultants. I don't like my own industry. It tends to attract nerds and anal retentive people who are interested in detail and not interested in the overall program to reduce risk. It's a bit like hi-fi magazines. Hi-fi magazines are the most concentrated source of bullshit in the planet. Because it's technical, they get away with all these things. And same with hand-arm vibration. So what I'm going to try and do is just go very quickly through some of the myths. And the main areas of myths are with risk assessment. People spend their whole lives measuring because it's easier than actually changing things to reduce risk. So I'm going to be talking about that. PPE for HAVs is an oxymoron. Tool maintenance vibration measurements, I don't know if it's the same over here, but they're becoming more and more common from suppliers. And the vibration values they give you to say, oh, it complies with the manufacturer's declared values and so on, not true in most cases. Purchasing or buying quite low vibration tools is very important, but on what do you base your decisions? And vibration reduction is normally regarded as you just can't do it. You buy a vibration tool, you're stuck with it. There are quite a few cases where you can actually do something about it. So any vibration risk management program has to contain all these elements. And what you're trying to do is say, what's best practice in my particular industry for each of these things? So identifying potential hazardous tools and operations. This is not always obvious. For example, a water pressure jet used to clear drains, you think, well, that's not a vibration problem. If you put it in pulse mode, you've got about 15 minutes use per day. So there are certain weird things or combinations of things that can cause problems. And it always takes, people ring up and say, we need a risk assessment done. And you say, well, we need a list of your tools in detail. And they say, oh, I'll get back to you next week. No, they won't. It'll be 3 or 4 months. People always underestimate the number of tools they have. Our current record holder is in South Wales. They said we've got about 100 tools. Currently, they're on 600 and still rising. So this does take time. Then you have to assess the risks. And how do you do that? And I'm just going to talk about the basic mistakes that people make. Training is really important because personal behavior, unlike most risks, has a big effect on your actual risk. And we have risk reduction programs by Smooth. I'll just touch on surveillance. One of the key first elements is a vibration management program is risk assessment. Now, there's a whole industry predicated on measurement. Measure, 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 measure. Placebo measurements. The problem is, you know you've got a problem, so you spend a lot of money every year remeasuring your problem, which says you still have a problem. It's exactly this big this year. It doesn't get you any further forward. But it's harder to do something about it. So you're looking at tasks and activities. You make a big list of them, and you then try and get a tool register. This bit's off the record. It's hard to get tool registers because there's a load of tools you don't know about in cupboards that get used once a month or something for particular jobs. So there's something you can do is spread a rumor that unless a tool is on the register, if you're going to put in a claim in the future, you can't claim. Then people are running after you with tools. You've got to try and get this list of tools, and it does take a long time. And what you need is details of how the tool is used, the materials it's used on. You want to know the make and model. Something called blue drill doesn't cut it. You know, okay, it's a drill and it's blue, but it doesn't actually tell you much about it as a piece of kit. So you're building up this tool register, and that is going to be the final, if you like, you need a list of tools that are acceptable within your industry, within your company, and you're not allowed to use any tools that aren't on this list. Vibration data. Have any of you measured hand-arm vibration? Handful of you. How did you find it? Very? Very subjective. It's also a pain. It's, you know, in our office, when a hand-on vibration job comes in, no one wants to do it, to actually do a measurement. It's time-consuming to do it properly, but unfortunately, the only way to get accurate data is to do it properly. Now, in the UK, the guidance from the HSE actually states, do not measure unless you have to. Get vibration data from reputable sources, field data as used in the field, in the sort of operation that you're doing, and do the minimum number of measurements, because you spend all your time and resources measuring and monitoring rather than on risk reduction. The other part of it is you've got vibration data to acquire off databases and so on. The other part is trigger times. It's how long you squeeze the trigger. If you say to somebody, how long do you use that angle grinder for? They're going to say 2 hours a day. Well, the finger on trigger time, people go, oh my God, 2 hours a day, he's well over the limit. But he's actually squeezing the trigger perhaps for half an hour a day. So you need to do that. And the way you do that is with very simple, there's tool timers around, cheap tool timers and so on that you can use. So you're assessing, what you're trying to do is to say, what is the dose per task? You're trying to acquire data that you can reuse. So if someone's doing up nuts on a wheel and they change the number of nuts, you don't have to remeasure. You just multiply it up so you can assess from your existing data. The whole aim is once you get a really good set of data, you get a range of values for that particular job. Every time you measure, you're going to get a different answer. The actual regulatory levels are finger in the wind. They're not that accurate. So you're trying to get enough data, and once you've got a good risk assessment, then you never have to repeat it. Now, hand-arm vibration measurements are expensive. You're actually going to physically measure. It's costly, it's time-consuming. Our rule of thumb is you can probably do 20 tools in a day if everything goes really, really well. Because it just takes a long time to do it. You have to arrange to get the tools there. You have to arrange for something to work on. If you're testing a load of breakers, for example, you need something to break. And the stores in which the breakers are held, they don't want you digging up their floor. So you have to find bits of concrete or go somewhere else and dig up someone else's floor. So the aim is to spend the minimum on assessment and the maximum on risk reduction. Just a quick technical aside here. If you double the vibration, you double the risk. But it requires 4 times the finger on trigger time to double the risk. So in other words, it's more important to have accurate vibration data than finger on trigger time. People get hung up, oh, it's 23 minutes. No, I think it's 18 minutes. It doesn't matter. It matters if it's 1 hour or 3 hours, but if it's a few minutes or 15 minutes out, it just doesn't matter. So measuring vibration is has to be slightly more accurate than measuring finger on trigger time. To the international standard measurement is you rigidly attach the accelerometer to the handle. And that's what all the risk statistics were done based on data. I'm old enough to have supplied some of this data on which risk statistics are done. You rigidly attach with a band clamp or a cable tie really, really tightly so it's absolutely immovable on the handle. That gives you a fairly repeatable measurement. You're still going to get a range of values. You cannot use things like hand-gripped accelerometers. I mean, I think that's probably what you're referring to, how tightly you grip it. They give you the wrong answer. A couple of examples here. On a grinder with a fixed accelerometer 2.2 meters with a handheld one 0.8 to 1.8. So between half and almost the right answer. On a high impact tool, we've got 18 measured correctly, 9.5 measured with a handheld accelerometer. And it depends how tightly you grip it. If you get a different answer with the way you're measuring compared with a hard-mounted accelerometer, your answer is wrong by definition because you can't compare it to the risk statistics. It's not to say at some time in the future they won't be able to invent a better way of measuring, but you have to spend years and years and years correlating it with the risk. Now, there are loads of new kit coming out with new accelerometers, new electronics, and all the rest of it, and this is confusing. And some of the wording used is confusing. Handheld transducers, which is a very common one, glove-mounted transducers or wrist-mounted transducers. And you get the impression from a lot of the literature that this saves time and effort and all the rest of it. In most of the literature, it does state that it doesn't comply with the standard. But a lot of end users are confused by this and assume it does comply with the standard. And you can underestimate someone's risk by a factor of 2 or 3 or 4 if you do that. So this is a big problem because of the technicalities of measuring vibration. So you have to be very, very careful. And to show you a few examples, if you read these and you're not a vibration expert, vibration measures vibration in hands, sensor attached to a special glove, everything you need for easy and accurate hand-on vibration measurement. Now, you'd assume that gives you the data you need. Unfortunately, it gives you the wrong answer compared with the standard. A wearable monitor records the vibration on the wrist. Now, again, that's even worse because, you know, if I undo my watch and let it slide like this, that's going to give me a totally different answer than if I tighten it up. Personal daily vibration dose, complying with all these standards. The equipment complies with all these standards, but these aren't hand-on vibration measurement standards. They're instrumentation standards. The measurement does not comply. It can do with a special adapter, which you clamp onto the handle. And we get consultancies. We had a course a few years ago, a local authority guy has his head in his hands because they get all their kit measured every year by a consultancy who strap the accelerometer on with masking tape, which is, you know, I said, sue them because you're underestimating the risks. So they're saying they use the latest gloves to measure vibration and triaxial accelerometer and so on, testing to the international standard, but the glove data is not to that standard. This is disingenuous and will seriously underestimate. And they don't use spell checkers. Maybe I'm nerdy, but I think that's quite important too on a technical document on the web. So the technical bits is the top one shows you how you should measure. You clamp the accelerometer to the handle because what you've got is the minimum number of variables. Effectively, you've got a spring and a damper between the accelerometer and the handle, but it's fixed. So it doesn't change. Your hand gripping the handle, the squidgy bit, which is your skin, the technical term for that is a spring damper. The tighter you squeeze, the stiffer it gets, and the higher the damping. So it's a variable, as is the same one in your wrist as well. But the connection between the accelerometer, the transducer, and the handle is not a variable. If you have a handheld accelerometer, the top picture is what you're doing. You are trapping the accelerometer between your hand and the handle. And as you said, the connection, the amount of vibration that gets transmitted and transduced depends on how tightly you grip. It also depends on the shape of the handle. So it's immensely variable. If you then put it on the wrist, you've got even worse problem. Because your grip strength varies, you're varying how much vibration transmitted to the hand, how much vibration transmitted to the wrist, and how tightly you do up your wrist-mounted transducer. Now, you can use that as a tool timer, and some of these systems will allow you to put in the correct vibration values so that you can actually calculate someone's dose in real time, but not using the value measured by the wrist-mounted transducer. So there's technical reasons for why they don't work, but you wouldn't get that impression. This is quite a high vibration job to measure, riveting. And if you watch, there's two things to do here. You have to measure on the back rear handle, the front handle, and on the button bar, the dolly that the other guy's using. The cable, those cables cost $600. Bluetooth is just about getting there now. So this system is a very difficult thing to measure. If you don't, you get a huge value, which means it's overloaded the instrumentation. You need to use what's called a mechanical filter, which filters out the high-frequency stuff, which stops the overloads. But to get that properly instrumented takes time. You have to clamp it onto the handle really, really tightly, and then you have to measure at 3 locations. And then you have to repeat that. What we do is we do 3 sets of measurements with 1 set of operators, and then if we've got time, we do another set of operators. But we also do, the transducers have got 3 axes. So there's 3 little transducers and 3 accelerometers measuring each of the 3 axes. And we always write down the values for each of those axes. Now, most people only write down the combination, what's called the vector sum, the overall value. But this is a pretty violent environment for electronics and accelerometers. The accelerometers we use cost about $2,000 in Australian dollars. We get through 2 or 3 of those a year. They break. But they don't all break. You get one of them breaks. And if you don't write down the values for each axis, you don't know that one of your transducers has gone down. And Sod's law says that's the transducer measuring the worst part of the vibration. So there's all sorts of things you have to do. This is a painstaking job. This is why we say you can probably measure about 20 tools a day if everything's really, really well organized. So the HC guidance says, please don't measure all the time. Try and use published data. Because to be honest, the only reason you're doing the evaluation is to say, is it going to change what I have to do in terms of risk management? If it doesn't, why worry about it? It doesn't matter if it's 3.5 or 4. You have to do the same stuff. The only time it matters is if you're getting very, very close to the limit of 5 meters per second dose for the day, then it does make a difference. But generally speaking, you're going to get a huge range of values anyway, so don't get hung up on the details. Just use generalized data. We do 70 to 80% of all our risk assessments now off our database. So it's a virtual assessment by email, which is a lot cheaper and quicker anywhere in the world. It works, and it also is probably better than measuring because you're also comparing the measurement on this particular piece of kit with lots of other measurements on the same piece of kit doing other things in other places. So you get a range of values, and that's all you're trying to get. And it is time-consuming and quite expensive first off, but you only have to do it once. And the only thing you have to do after that is if you're going to update it, then all you have to do is, if you get a new tool or a new process, just do that. The rest of it, if you don't change, you same angle grinders, same process, you never have to repeat it. But this is one of the questions you get, someone puts their hands up, but surely you have to measure the vibration from that guy's tool because his tool may be knackered. Well, yeah, you could spend if you measured it every week for 4 years, you get a different answer every week. All you want to know is what's the range of values likely to be. That's it. And the amount of data you need to determine this, for example, this is angle grinder, and someone phoned up saying, I've looked up this angle grinder online, and the values range from 2.4 meters to 12 meters. Now, 2.4 is no hazard at all. 12 meters is a serious problem, which is correct. Well, the issue is that the database didn't have what it's being used for and how it's being used. If you're cutting off, it's probably 12. If you're light fettling a weld, it may be 2.4 meters. So you need to know how the tool is being used to get accurate data, and it does make a big difference. So you can download this free template, our template tool register, which is to get away from just the blue drill syndrome. You need to know the make and model, and you also need to know what accessory it's being used with, what it's being used on. Is it used to cut plastic or metal? Is it being used on tarmac or concrete? Because they all give you different, if there's a breaker, you get a different answer from tarmac and a different answer on concrete. Also, if you have a blunt tool, the idea of having a sharp tool seems to be a real novelty in some companies. And also, there's loads and loads of factors that affect the amount of vibration you're going to get. And so you're just trying to assess, okay, I'm going to compare this database value with what I'm actually doing. I want to get pretty close. I'm using it for cutting off, therefore it's this set of values. And our database, while we're at it, you can see here that we do put in, we do have in the X, Y, and Z values for the side handle, the rear handle. On some tools, you may have to measure 6 places, because on things like the big powered wrenches used on railway tracks, for example, the rear handle, depending on the angle of it, you hold it in several different places. So on one tool, you may have to measure in 6 different places to find out which one's the highest. We also include noise as well while you're at it, because you may as well for mobile plant and so on. And photographs, so you know exactly what it is, and online as well. But this is the sort of data we end up with. And here we have, this is leaf blowers, this big bar here. It's plus or minus 1 standard deviation for leaf blowers. And here we have a rivet gun. And the thing is here that leaf blowers is a massive variation. So what you're after is for leaf blowers, this is the range of values. If you buy a really good make with low vibration features, this brings down the top one, the top end of it. But what this shows you is that maintenance is a big issue on these, because we're measuring in the field as found, not brand new out of the box. So with rivet guns, it doesn't matter whether they're knackered or not, it doesn't make any difference to vibration. So you can use this to guide how you do your maintenance. I want to concentrate on the piece of the kit where the vibration changes most when you don't maintain it properly. And this is a case in point. The declared value, 480 minutes, and actually a measured value, it's 2 minutes. So it's an extreme case, but you can be quite a long way out. Just a throwaway thing, because this is, we've been talking about this for years, but people go, that's a brilliant idea. If you measure noise, measure at a couple of meters away, and you feed it into your spreadsheet that you used for the hand vibration and noise, and then you can put a sticker on where PP within 4 meters. Or 8 meters, or 2 meters. Gets around all the mess of measuring and having to be an expert. Everybody knows what where PP within 4 meters means for that particular piece of kit. And if you're using database values, you can get it from anywhere in the world, as long as it's comparable with the way you're using the kit has been measured properly. Risk reduction program. The usual thing first off is PPE. This poor guy has been told, go forth and descale that valve. So he's going forth and descaling it, and he is wearing a hard hat, he's wearing his earmuffs, he's wearing his goggles, he's wearing his mask, and he's got gloves on. They're all PPE except for gloves, and there is no PPE. The HSE say in their documentation there is no generally effective PPE. One of the reasons we were asked to do the roadshows with them is because if you're an HSE inspector, everything you say gets taken out of context. But I'm allowed not to be politically correct. I can say these things do not work. They're called anti-vibration gloves. It's not what they do, it's just what they're called. The weasel words, up to 70% reduction in vibration. You know, that's between 0 and 70%. It's like shampoo adverts. Up to 100% effective in reducing the signs of dandruff. That's the signs of dandruff. Now, what is this? On a misty day across a room with wearing sunglasses, it's signs of dandruff. If you can't see it, you know, I wouldn't like it if my pilot, when I'm flying to Sydney on Friday, said, I'm up to 100% sure I can get us there safely. The weasel words they're not lying. It is can reduce vibration by up to 70% at frequencies that are so high there are no interest whatsoever. On most typical, if you do the calculations, on most typical things, it increases your working time from something like 90 minutes to 91 minutes. And also, because you have to squeeze it harder, because they're so unwieldy and they're very expensive, it probably puts your risk up. It's very, very simple. Personal behavior. This guy is a classic. You could resist a picture like that. He's got these newfangled earmuffs that work as long as they're in the vicinity of your ears. He only needs to be seen from the back, not from the front, and only one glove to keep his hand warm. And it's a serious risk, 12 minutes, 48 minutes a day and at the limit. It's human behavior. This is why training is so important. Unlike a lot of other risks, the way he behaves affects his risk. Keeps his hands warm, exercises, wears gloves. Ordinary gloves, not anti-vibration gloves. Can you play the video, please? Human behaviour. So training and the way you educate people is so much more important for hand vibration than a lot of other things. Tool maintenance, very quickly. Again, here's the range of values for angle grinders and for leaf blowers and rivet guns. Now, angle grinders, leaf blowers, you need to maintain them, otherwise the vibration goes up. Tell your guys or girls, you know that angle grinder's knackered, still does the job, so if it's knackered and high vibration, put it in for service. Suppliers do hand-arm vibration meter tests. They run the tool, quite often they'll provide data, they run the tool light and say, this shows it complies with the manufacturer's declared values. It doesn't, because the manufacturer, they're not doing it to the same standard as manufacturers. And it doesn't tell you anything about the tool condition, because the hand-arm vibration meter filters out all the interesting information that tells you where they fitted duff bearings when they repaired it. Skipping over that one, you can do it, but you have to do a full signature. You have to understand whether the mechanics of the tool are in the same condition as a brand new one. And that's what you're doing. You're comparing complete vibration signature with a new one, and then you can say, yes, this tool is within specification. Vibration reduction, a couple of things. Pedestal grinding down from 32 meters to 1 meter per second by basic backstand grinding, just a very simple modification, mount it off the floor instead of off the tool. Riveting aluminium panels with a rivet gun, change the design of the jig to reduce the vibration. Reduce the riveting time by 50%, so you actually got productivity gains. It pays for itself in about 3 months and eliminates the risk of hand-on vibration. Bolt tightening, changing the way you do it slightly. I'm running out of time here. So this one, they use a sort of a rammer, converted rammer, to compress concrete into a lintel, into a mold for concrete lintels. Very high vibration, 28 meters per second. They sent us that video. We designed a retrofit kit. The next week it was fitted. Vibrations down to less than half, which meant, and also put up productivity. So we do noise and vibration control by video from smartphone all over the world now, because the technology allows you to do that. In certain cases, you can do these sorts of things. In other cases, you can't, but sometimes it's very, very easy. And those two cases actually improve productivity as well. We also did some work on mowers. Within 3 hours of being on site, it was down from 6 meters per second down to 1 to 2 meters per second by modifying the way the handle is mounted. Purchasing and hiring is quite an interesting one. Most hire companies use manufacturers' data only, because the manufacturers are their client, if you like, and they can't say your data is suspect on certain tools. So the traffic light system, that's an actual quote, amber rock drill, 5 to 10 meters per second, up to 2 hours use without further risk assessment. I would say that's safe to use for 2 hours a day, based on that. We measured it. It reaches the exposure limit value in 20 minutes. So can you sue them? Because your guys have been using that and got hand-on vibration damage because they underestimated it. So comparing suppliers' data, these are extremes, but just shows you what's possible. A grinder, quoted value 3, 5 to 12. Damped chipper, less than 2.5, 17 meters measured. Damped riveter, less than 2.5, 8 measured. And just to round off that, those are all the elements you need for a risk management program. And you have to make sure that you have best practice in each single one of those to make it all work. So those are the major myths. And fundamentally, what you're trying to do is to get an accurate evaluation so that people aren't going to be exposed to high levels of vibration. Assess the risk, just what you need to decide what to do. Don't spend all your resources doing it. I'll finish off with a story. There's a company in the UK, and all they do is dig trenches alongside of roads and motorways. They spent £100,000 on a continuous monitoring system, and they're spending thousands and thousands of pounds a year on software licenses and things. If they spent, but the way we would have done it is said, okay, we do a few measurements, and you work out the risk per meter of trench, and that's it. If they'd spent their £100,000+ on low vibration breakers, they would have not had a problem in the first place. There's this great industry predicated on measurement and assessment. You should concentrate on risk reduction because that affects people's lives. Thank you.
Thank you, Peter. Unfortunately, we don't have
Time for questions. I should be around, floating around, especially at lunchtime, because I gather there's food.
There we go. And on behalf of the AIOH
Thank you.
Conference Committee.
Thank you very much indeed. Thanks, Ross.
Thanks very much.
Cheers.